Okay, I wanted to show you the motor controller mounted in the box. Well, it's not mounted, and this is what it looks like when it's inside the box. The two circular parts of these mounts fit around the push button switches. Like I said before, the cutout on this one is for the heat sink, and the cutout on this one is for the Arduino. It hits the shield portion, so you have to put a little cutout in there. But that's the spacing between the bottom of the box and the top of the part. Now this little thing that sticks up here, when you put the top of the box on, there's like, I think, a 1/4 inch gap between this and the box. So you really can't make this too much higher. You really can't make it too much lower. I don't have the cutoff in this heatsink, but this is what I was explaining to you, is that there's not much gap in there. You see, it looks like it's going to hit. But anyway, the little wrench I was telling you about is for when you put the nut on here. You have to have this little wrench to get in there. You have to get it from, you have to put these black pieces on first, and then you put the motor controller on, and then you get it from the inside. Actually, it's from the inside, not the outside. And you just rotate that and tighten those push buttons. That's what this is for. Little offset kind of wrench thing going on here. I mean, you could tighten it with a pair of pliers, but I just didn't want to do that. I mean, I know there's only two. This one and the one on the other end, but I just didn't want to do it. So I wanted to talk a little bit about these push buttons. Now these push buttons, when I put these in, I know sometimes you put buttons in and you go to tighten the back and they start rotating and you can't tighten them. So what I do with these is I put a little notch in them. There's a little notch right here. This is a 5/8 body, so I put in a vertical collet. And I just took a 1/8 end mill and I just come in here and just put a half a circle in there. Just come in and out, half a circle. It's a anti-rotation circle. So I did that on all of them. So of course, anytime, I didn't want it to rotate, and I got an anti-rotation thing in there, so I had to make an anti-rotation thing to hold it with. So I made this guy here. This is just a piece of aluminum, and what I did was I put a 1/8 diameter dowel pin in here, the radius of the circle, and I needed to sit flat. You know, sometimes you drill a hole, and because of the drill or the reamer or whatever, you can never get the true depth on it. So I put a cutout in here so that the dowel pin sits flat against that cutout, and then I ground the dowel pin so it's perfectly flat on top because I didn't want it to scratch the surface of the box. So what that does is that allows me to put this in here, and I rotate it until that comes with that. Then it sits on there flat and it won't rotate. You lift it up a little bit, you can't get it in, but then when it hits that dowel pin, it goes right down. So I hold this, and then I tighten the back with this guy, and that way I can tighten the nut on here without this rotating. Now, of course, when you got these parts and they're in the box, you want them to line up. You don't want one this way, one that way, and it'll look funny, you know. You want all these notches in one direction. At least I do. So I put these, when I had it set up, I took the same end mill that I used to set that, and I made little notches on the outside of this part, so that they're 90 degrees from each other, so that when I'm looking at this tool, because you can't see where the notch is on the push button because it's inside the part. So to get a visual, I put notches on the outside of this part so I could tell, well, this would be the top, this would be the left, this would be the right. Or if I want to make that the bottom, you know, I'd make that the bottom. And so I have an orientation between where this pin is and where the outside of the part is, so that when I go to tighten it, I know that I put these all the same, and all the notches are going to be in line with each other in all the same direction. Now, the thing is that when you put these push buttons in this box, you barely got enough room to put the nut on, because when you put the nut on, the first couple threads, they're junk, you know. That's from where they run a die on it or whatever they do. But you know, you got to get down like 2 or 3 threads before it actually starts gripping. And the thing is that when I made these standoffs, because these are whatever I said they were, 80 thousandths or whatever. Yeah, 82 thousandths. What happens is that the button, or the push button, is now 82 thousandths taller than what it's supposed to be. I don't know if you can see that, but now you can't get the nut on there. It'll go on, but it never tightens because you're hitting that 1 or 2 threads on top that it doesn't let it tighten. So what I had to do was I countersunk this plate these adapters, these height spacers for this are these two, because this is how it sits on the back, like this. It sits like that, inverted on the back side, like that. So these two I sank into the plastic. I think it was another 60 thousandths. But because I had the notch on it, I had to incorporate the notch into the plastic, the anti-rotation notch. So I did that on these two. Now I could have done it on all of them, but I went through all the trouble of making this tool up, so I wanted to use it. I know it sounds crazy, but I didn't have to recess this, and you really don't want to recess it too much, because then you weaken the plastic. I mean, you can see how much thinner it is. I mean, it would have been fine, but you know, I wanted to use this tool. So anyway, just be aware that you're going to have to countersink or counterbore this plastic for these two screws if you go with this, because you really don't want to make these any thinner. I thought about making them thinner, but I really didn't want to. And I didn't want to make them out of metal. I mean, they're made out of Delrin, but I mean, if I had a 3D printer, I could have made all these plastic pieces off a 3D printer, and they would have been fine. There's really no stress on it. There's hardly any weight to this thing, and there's no movement in it, and it would have been fine. And that other piece I was talking about was this piece. This is it connected. Like I said, this is like a clamping nut, and then this piece comes out, and it's got serrations on it to keep it from rotating, and it's got serrations in here so that when you put that in there, it keeps it from rotating. So when you put this nut on there, that keeps the whole thing from rotating, and it clamps down on that. So the wire is going to come out of there, and I'm going to clamp down on that, and that's what it looks like inside there. As you can see, I don't know if you can see it, but it just barely fits in there against that wall. There's a lot of room on the inside here, so that's where I use my little tool. And just snug that down, hold on the outside and just snug it down, and that thing's nice and tight. Because this original piece, that's 8/68, pretty much 7/8. Then the outside of here is 9/50. So I made this other piece, made the outside of this 8/75, 7/8, because I was originally going to make it like 8/60 or 8/50. Could have made it smaller, but then you have the problem with is how you're going to put the notches in it. So what I did was I figured, well, I can work with 8/75 inside this part, inside of here. Actually, what I ended up doing was I made that just a little bit bigger than what it was. Put it in a forward jaw, indicated that, and had to come in there with a little boring bar and just kind of touch the wall there a little bit. Made it a little bit deeper too, because you can see that it's I mean, there's plenty of thread on there, but it doesn't hurt to have a little bit more. I mean, there's really no stress on this part at all. It's just holding the cable. But anyway, getting back to the diameter of this part was that, I wanted to make it smaller, but then I couldn't, and then in order to put the notches on it, I had to put clamps on it or something extraordinary, which it really wasn't worth it. So I made it 875 so I could stick it in a collet and just run an end mill across it. And these are about 1/8. I think I made these lugs just under 1/8 because I didn't want to get too fancy. I mean, I made those a little bit under 1/8, and I took an 1/8" end mill and just ran through there, and then just kicked it over 5 on each side, and that was plenty good enough to hold that. But yeah, that's what I did with that, and that worked out pretty well. So anyway, I think we're getting somewhere. So I just wanted to show you that, so that you know in advance if there's something else you want to do different, or you want to do it the same way, or. And then I got this other little part. I wanted to show it to you. Now this piece is going to mount on this board right there. Now what this piece is remember that little diode thing? This guy here. There's one of these you have to add into the system between the plus and the minus, and I don't think it's really a diode or a rectifier or whatever the thing is. I don't know what it is, but anyway, you have to put it in the system. So I made this little piece for it, and what it does is it just fits inside of here, and it just holds it, and then this just mounts onto this. Take this screw out, and you put this one in its place, and it mounts right there. Now when I wire this thing up, you'll be able to see it, because I had to put it somewhere, and I just didn't want to leave it laying on anything. So I made a little mount for it. It's just a little hole and a little circle and a little flat and a little thing to fit right there. So you'll see that later too, when I get to wiring this thing and putting it together. I got some 22 gauge wire, so I can start soldering this up between the switches and the shield and the Arduino. All right, talk to you later.